This is homework 20. Attempt all problems and show all work. Box answers. Highlight any problems you may have questions on. Decide whether the graph represents a function. So if they give us a graph, I'm going to do the vertical line test. That only crosses at one point, so yes, that's a function. This one crosses at 2 points, so no, that's not a function. Yes, this is a function. And this crosses at 2 points as well, so no, that's not a function. Which relation is a function? Well, why would this not be a function? Because it's a vertical line, so vertical lines aren't functions, so that's a no. This one, 1, or negative 1 goes to 1, 2, there. Is it okay that 3 and 4 both have an output of 2? Yes, that's okay, so that's a yes. C, 1, 2, 2, 1, 3, 0, 3, 4. We can't, for an input of 3, we've got an output of 0 and an output of 4, so that's a no, because they've got two different outputs. Same thing here, for an input of 3 we get an output of 3, and for an input of 3 we get an output of 5, so that's a no. This 3A, that crosses at 1, 2 points, so that's no. Is it okay that two inputs can have the same output? Yes, just as long as every time we output a 2, or we input a 2, we output a 0. Or a 4, we have to get to 0. So that's a yes. When they give us numbers, look for inputs to repeat, because that's really the only way they're going to show you that it's not a function. So if you don't see any inputs that repeat, you're probably going to be dealing with a function. Negative 3, negative 7, negative 4, negative 1, those are all different, so we couldn't even tell if it had the same input, if it would be different. Same thing here, negative 2, 0, 2, and 4, we can't tell. So this is a yes, and this is a yes. Those are all functions. Question 4, what is the domain of the relation below? Domain is the x values, so the domain would be negative 2, negative 1, 0, and negative 1. Or we don't need to use the negative 2 or negative 1 twice. You don't need to list that twice. So it's just negative 1, or negative 2, negative 1, and 0. Negative 2, negative 1, and 0. D. 5, what's the range? Range is the y values. So this looks like negative 2, 1, and 4. We don't need to redo the negative 2 twice. So negative 2, 1, and 4. We'd write that in ourselves. Negative 2, 1, and 4. That's our range. Problem 6. If we wanted to find f of 3, this looks like it might be from our notes. We'll substitute in a 3 for x. So I'm just rewriting this problem right here. F of 3 equals negative 5 times the quantity 3 squared plus 3 minus 2. So we need to square 3, that's 9. Negative 5 times 9 plus 3 minus 2. Negative 5 times 9 makes negative 45 plus 3 minus 2. 3 minus 2 is 1. So what's negative 45 plus 1? Negative 44. So that's f of 3 equals negative 44. 7 says, explain why the distance you travel on your bike is not always a function of the time you spend riding your bike. Describe a situation when it would be a function. Alright, is not a function of the time you spend. So, why distance you travel on your bike. So why would this not be why would it not be a function? Well, it could be a function But what else? Time you spend riding your bike. Well, it's not always a function of the time you spend riding your bike. Describe when it would be a function. Distance you travel. And I'm going to make an argument that because it says distance you travel, spend riding your bike. If you're riding your bike, that would be like the definition of riding your bike. You're traveling somewhere. Now, if you're with your bike, that wouldn't be riding it. That would be like stopping, when you're stopped at a stop sign, but you're not riding your bike. So I'm going to say it's always a function. But what they're looking for you to say is when you're not riding your bike, that you're not going anywhere, so it's not, so your distance wouldn't be changing, so you'd be in a vertical line. But it's a bad question. Decide if the point lies on the line, show all of your work. So here we're just substituting in these points for x and for y. So if I zoomed in here, we'd say 2 times 2 plus 4 times 1, and see if that equals 8. 2 times 2 makes 4. 4 times 1 makes 4. Does 4 plus 4 equal 8? So that would be yes. Next one, 1 for x, negative 2 for y. 2 times 1 plus negative 2 equals 0. So that's 2 minus 2. Does 2 minus 2 equals 0? Yeah, 0 equals 0. So that's a yes. 10, 2 for x, and a negative 1 for y. Negative 3 times 2 plus 6 times negative 1. See if that equals negative 9. Negative 3 times 2 makes negative 6. 6 times negative 1 makes negative 6. And negative 6 minus 6 makes negative 12. Negative 12 does not equal negative 9. So this is a no. Seven, rewrite the equation in function form. That means to solve for y. And create a table of values using 2, negative 2, and 0. So x and y, negative 2, 0, and 2. That's what it wants us to use. X and y, negative 2, 0, and 2. First we need to solve this for y, so we'd add 2x to both sides. And we get y equals 2x plus 6. So first we want to substitute in a negative 2 for x. We're going to do this one first. So 2 times negative 2, negative 2 plus 6. That makes negative 4 plus 6, which makes 2. So that's the point negative 2, 2. Let me look at this. Negative 2, 2. Y equals 2. There's our XY table, or our XY coordinate plane. So negative 2, 2, negative 2, 2 would be right here. Okay, next we'll plug in a 0. So I'm going to use the same spot here. And now we'll just substitute in a 0 there. What's 2 times 0? 0. 0 plus 6, 6. So that's 0, 6. 2, 4, 6 right there. 0, 6. And next we're going to substitute in a 2. So 2. 2 times 2 makes 4. 4 plus 6 makes 10. So that's 2, 10. 2, 10 will be, up here somewhere. So we have this. Make our line just like that. B, we need to add x to both sides to solve it for y. Y equals x plus 7. So the first one we're going to substitute in a negative 2. Negative 2 plus 7 equals 5. Right? Next we'll sub in a 0. 0 plus 7 equals 7. And the last one we'll plug in a 2. 2 plus 7 makes 9. So negative 2, 5, 0, 7, 2, 9. We can go like way down here. Here's our x, y graph. Negative 2, 5, 1, 2, 3, 4, 5 right here. 0, 7, 0, 7, and 2, 9, 2, 9. Those are our points. Eight says it takes 150 hours to resurface 30 miles of road. Write a linear function for resurfacing d miles of road in t hours. 150 hours to resurface 30 miles of road. So 150 divided by, 30 divided by 150. We want to find our slope. Get out of there. So this is 30 divided by 150. We're going to find out how much we go in 1 hour. So 30 divided by 150. That's 0.2 miles an hour. That's how far we're resurfacing. That's really, really fast, actually. Almost a quarter of a mile in an hour of resurfacing road. Yeah, it's very fast. So write a linear function, t hours. So d equals 0.2 t. There's our linear function right there. Create an input-output table for the function. Find the length of the road in 500 hours. So it doesn't tell us which ones to use. So let's use an input of like what do you want? 100, 200, 300, 400, and 500. That's our t values here, and this is our d of t. Okay, or normally this would be called our x, and this would be our y. So when we plug in 100, so this would be 0.2 times 100, which would be 20. When we plug in 200, 0.2 times 200, which would be 40. 0.2 times 300, which would be 60. 0.2 times 400 would be 80, and 0.2 times 500 would be 100. So we're going, the length of the road in 500 miles would be 100 miles. Or sorry, 500 hours would be 100 miles. So graphing this function, it's not going to really be to scale because our x's and our y's are off as far as what we want them to. We're talking in hundreds and we're talking in tens, so it's going to be a little off. So our t value or our x values need to go in groups of 100. So I'll say 100, 200, 300, 400, 500. And we need to go from 20 to 100, so 20, 40, 60, 80, 100. Perfect. So our first one was at 100, we were at 20, so that's right there. At 200, we were at 40, that's right here. 300, and you guys can finish this. So there's our graph. And that looks like homework 20.